Hello, my name is Tim, and today we're going to be talking about capacitors. The three functions of capacitors that we'll be speaking about today are: number one, the capacitor is being used as a storage device like a battery. Number two, capacitor is being used as a DC blocking device that will allow DC voltages to pass. And number three, to be used as a phase shift for AC, a 90-degree phase shift between the current and the voltage as illustrated in this diagram. Now first of all, we're going to talk about it as a DC blocking device. What I have here is I have a power supply, and the power supply is on, and out of the power supply I have one lead going around to my capacitor, going in the capacitor, out the capacitor, out of the capacitor, and to the light itself. As we can see, that light is not on. So that would appear to confirm that capacitors actually block DC. However, I could be trying to fool you. I'm not. You can trust me, sort of. Okay? So if I was to actually jump across here, across the two red wires, if the capacitor is actually acting to block it, this light should actually come on. And it does. So this would appear to confirm, based on this, that I've got one wire coming from my power supply up into my capacitor, out of my capacitor, and to the other lead, to the light. The other lead here was simply going to the other side of the power supply. So that confirms that capacitors can be used to block DC. Now in AC, capacitors can be used to create a phase shift. It becomes very important when we're trying to start motors, to give that rotor the opportunity to start that motor in the proper direction. Now, what I have here is I have 115 volts. I have the black lead, which is going straight over to the light, as you can see here, to my light bulb. Then I have my neutral coming to a capacitor over here, out of the capacitor, and to the light. This gives me my 115 volts. But if I'm correct, it's actually going to be in a 90-degree phase shift. So let's see if the light lights, which it does. Now, I could be wrong. Could it be that this is actually allowing that signal to pass straight through unobstructed? Well, if that was true, that between here and here, it was just the same exact waveform, it was just passing straight through, that means that if I was to take this lead and jump it to here, then nothing would happen. Well, I'm here to tell you it would. Okay, it would blow the fuse, it would blow the circuit breaker, and the light would actually go out. But what I've actually done to prove this is I've gone to another capacitor. I've come straight out of this capacitor and straight to here, through the light. Now I've taken straight from here to this other capacitor. This is acting similar to this. Now this light right here has the neutral wire to it. This is my hot lead going to the light. I've simply attached another wire to an ammeter so I can see it, which you're going to see in a minute. Now, if I was to simply touch this to this, if it was a dead short, the light would go out, the circuit breaker would blow, and this would probably catch fire. Kind of cool, but not going to make you very popular. However, there is a little bit of phase shift here because of the voltage imbalance from this side to this side. So it'll spark a little bit. Hopefully it won't explode. That's why I have my glasses on. If I touch it, get a little spark, light stays on, not a direct short. Put it on, off, nice little spark there. But it doesn't short out. Once it's made, it's made. It causes that spark because when I pull it off, it's no longer balanced. If I do this, now it's balanced. So, where I touch that, and when I touch it in the waveform, it's going to give me a bigger or smaller spark. So as you can see, the light did not go off. The reason for this is the 90-degree phase shift. What's happening is there's actually time delay between when I charge this capacitor up and it actually discharges out the other side. To illustrate that, imagine this as the incoming voltage and this as the outcoming lead to the capacitor. Now what's going to happen is this is going to charge that capacitor up. So as my voltage goes up, now the capacitor is fully charged and now I can have my current going out. This is the going back and forth motion of charging and discharging that capacitor. And this will continue as long as I have power applied. About 60 cycles a second, ups and downs for the AC, or 120 total ups and downs per 60 cycles. So again, one cycle is completely going from 0 to 360 degrees. Going up, passing 0, and going to its low point and then its maximum. Continually going, charging and discharging. Now capacitors come in many different sizes and shapes. They can come from very small capacitors, larger capacitors, these are used for starting. These range usually in the microfarad ratings of up to and exceeding 100 microfarads. They can come in, for example, like this, a single run capacitor, usually rated for a much smaller microfarad reading. They can come in multiple capacitors in ones. As you can see, I have 3 leads here. So in this case, it would be 2 run capacitors for one motor and one condenser fan, let's say. And these can come in different sizes as well. As you can see, these serve the same function with 3 leads. One for one motor and one for a different one. So, capacitors can come in many different shapes and sizes. Capacitors will store voltage similar to what we see here to be used for later, and they will discharge that just like a battery. Capacitors can be used to block DC. A great application is in filtering for noise or other things that I don't want on the circuit, and keep a nice pure clean DC signal. It can be used for creating a 90-degree phase shift. Thank you very much for exploring capacitors with us. Hopefully you'll come back and partake more of our knowledge. And I ask you to think about one thing. That your future, you can either be a conqueror or a victim. A conqueror takes charge, makes his or her own future. A victim simply waits for things to happen and becomes a victim of their future. Go forth and be a conqueror. Knowledge provides you that opportunity. Thank you very much. Tim out.